Hello, everybody. Christoph, could you go to the next slide, please? Yes, thank you very much. So first of all, thank you all for joining today from all over around the world again for our webinar about our complete QCAM series. We are very happy to see again a huge number of participants for which is already our 6th webinar of this year. So thank you all for that. Today we are going to explain you a bit more about our new and complete QCAM series ANPR cameras, explaining the cameras itself, but also their features and even giving a live demonstration. Yes, Christoph? So today I will be your host. The webinar itself will be given by my colleague Christoph Stout, who is our account manager for the DACH region, so Germany, Austria, and Switzerland. If you have any questions during the presentation, please feel free to ask them in the Q&A area of this Zoom webinar. At the end of the webinar itself, we will then be going over as much questions as possible. And if you still have any questions, please feel also free to contact us on the email addresses mentioned here in this presentation. So I will now give the word to my colleague Christoph Stout and wish him good luck for this very interesting webinar.
Yes, thank you very much, Pierre. So hello and welcome also from my side. I'm very pleased to present this very important webinar to you today. So first of all, I would like to give a short introduction of our company to those who don't know our company yet. So MACQ has been founded in 1923 in Brussels. It's a Belgian family-run business. We are currently over 130 engineers, mainly software and hardware developers. We have two business areas. So first of all, the smart mobility ITS world, and on the other hand, the automation area. Our business model in general is to sell self-developed products, and on the other hand, also to develop customer-specific turnkey solutions. We develop intelligent cameras, so it's also to the topic of today, of course, since 2001. So that means we, since 20 years, we gained a certain experience how to improve the algorithm, how to improve the recognition of vehicles, but also in general, the traffic. And so we develop not only the hardware of these cameras, but also the embedded software. As our products are especially designed not only for a local market, but a worldwide market, our sales is also focusing on many countries like France, Netherlands, Germany, Switzerland, Austria, Denmark, but also outside the European Union. That means the UK, the US, Morocco, Turkey, Australia, Vietnam, only to give you some examples. So this was the short overview. And now let's get started with this webinar about the QCAM series. The QCAM series, so I'm very pleased to announce you 5 new cameras today. So first of all, our QCAM 3, it's a small but very efficient camera for recognizing vehicles up to 2 lanes. It has a 1 5-megapixel color lens. Then our QCAM 5, which exists in 2 editions. Both editions have a powerful NVIDIA chip embedded, which makes it possible to recognize also vehicles in very dense situations. And as you can see, it has 2 5-megapixel color lenses, 1 color and 1 black and white. So the first standard edition is the standard QCAM 5. And then we have the QCAM 5P, P for polarized. And this is a very special camera which allows to see within the car, within vehicles. And this allows us to count people, count passengers in the car. And this is, of course, a very special camera for our carpooling solution, especially. Then we have the QCAM 7, also in 2 editions. Both editions have 2 12-megapixel lenses, so it's a very high-resolution camera. And it has also a very powerful NVIDIA chip embedded, which makes it even on a very highly dense traffic also capable to recognize all vehicles. So first edition is the standard QCAM 7, And I think the second edition will interest a lot of people. It's the QCAM 7 Plus. It's our QCAM 7 with an integrated radar. So what you see here, the QCAM 7 on the right, the gray housing, there is in the QCAM 7 Plus also already the radar integrated. So this means, of course, it's our special solution dedicated when it comes to speed monitoring. So to give you a short overview or a feeling about the dimension of those cameras, I want to compare it with a standard notebook. Here you see a notebook, and here the housing of the QCAM 5, the QCAM 5P, the QCAM 7, and the QCAM 7 Plus. All these 4 cameras have the same housing dimensions. And as you can see, it's exactly the same height as your notebook. If you are now see this webinar on the notebook, you can just compare it with your notebook, and you know how high these cameras are. And the QCAM 3 is even smaller. As you can see, it's not even 10 centimeters high and less than 15 centimeters wide. It's also a common feature from all these cameras is that you are able to change the positioning, the angle remotely. That means you can change the pan and tilt from distance from your computer, and you don't need to go on location, and which is of course a great advantage for installation, as you don't need to block the road as long as usual. And this has of course an impact directly on the costs of the installation. Which is important to mention is all these cameras are 100% developed by MACQ. That means not only the hardware, as you can see here's an example of the QCAM 5 with a PCB, it's developed internally and also the software, so not only the hardware. To give you the main difference between with our previous camera series, because lots of you already know our eCar series, the D3 and the D3 Plus, etc. So the main difference is that we now embed AI, artificial intelligence. And what does it mean? That means we are able now to recognize not only license plate, but even more characteristics of vehicles. And this everything on the camera itself. So that means you don't need to send it somewhere to be analyzed. Everything is analyzed on the camera itself. So the great advantage of this is, of course, that you can process in real time. You can anonymize data on the cameras. That means you have, from the GDPR point of view, it's very interesting because you don't need to send any images with personal information somewhere. So you can only if your need is to have, for example, a certain statistic, the camera itself can send via CSV or an XML file these statistics without personal information. It can be even anonymized with hashing. So, and this allows also to lower the bandwidth use of the infrastructure. So very interesting features from the new camera series. To give you an example, what is the difference between the QCAM series and the eCar series before? So before, the cameras are mainly recognizing the whole image by OCR. That means the whole image is scanned, and the OCR is detecting characters on the whole images and recognize them. Now, with the QCAM series, there is an OCR, but on top there's also AI. And to give you an example, what does it mean concretely? So first of all, instead of scanning the whole image, first of all, we scan the image and we detect the license plate as an object. And then in this region of interest of the license plate, we are detecting, thanks to our OCR algorithm, the license plate itself. So this is the difference, but the AI is not only capable of detecting license plate as objects, but we are, of course, have also our object detector in general. That means we are able to detect other objects. Here, a short or an example of an image. And to give you some examples, what we're also able to recognize with our AI, with our QCAM cameras, is, for example, the train. So once the camera sees a train, it can say, okay, here I see this train, and can trigger something externally. the barrier, of course, but not only. It can be recognized as a barrier, but also as a barrier when it's only moving. Then the traffic light, when it's blinking, for example, the object on the level crossing itself. So if we detect there's an object which is not normally on this surface, as you can see on the right-hand side with the blue rectangular, then we can also trigger like an alert to a central traffic management system. Then we are able to not only to detect cars and vehicles, but also cyclists and pedestrians. So only to give you some examples regarding our object detection possibilities, here's some examples. So here you can see a picture from the Champs-Élysées. Everyone probably knows this famous street. And on the left-hand side, there's a red truck. And all our QCAM series, what are they capable in detecting? So all the cameras are registering following information. So the license plate and the country code. We are able not only to detect all European countries, but also other countries, license plate from other countries around the world. Then we are classifying all vehicles in 10 classes or more, in this sense, the heavy truck. Then we detect the ADR plate. As you can see on the truck, you see the orange plate on the left side on the bottom more of the truck. And this there, if you zoom, you can say there is 1824. So we are detecting all these kind of plates. Then the make, here Mercedes. So we have in our database more than 180 makes, 180 different car manufacturers, and more than 1,300 models inside our database. And of course, the color, we have 10 different color we differentiate. On the next level, regarding the movement characteristics, you can, on the camera itself, I can show it during the live demo in a few minutes. You can define the lanes, and then the camera detects on which lane these cameras are driving. Then, of course, the camera is able to detect the direction and can therefore also detect both, so vehicles driving in both directions simultaneously. And on an image-based analytics, we are also able to estimate the speed of the car, here 56 kilometers per hour. And last but not least, our camera has a GPS and a time synchronization with NTP server and with a GPS. So we are able to have a very precise, accurate location and time stamp. All this data, which is processed within the camera itself, can be then transferred to a central traffic management via like the cable, like Ethernet, or via Wi-Fi, 3G, 4G, and if your infrastructure is capable, also now with 5G. Let's start with a short live movie. Therefore, I switch my screen to the web browser, which I already prepared, of course. And here what you see is the interface of one of our camera in Brussels. So that means with a simple IP address, you are able to connect in your browser to the camera itself with a login password, etc., with all the authentication and security aspects. You can log in. And afterwards, you are able to see this screen. This is the embedded software on the camera itself. If you click here on the arrow, you see, first of all, a live stream of the camera itself. So this is a black and white image. It's not very smooth because, of course, this we have make by purpose to show you it's a 4G network. So it's even to give a short overview what is going on your location, how the positioning of the camera is set, etc. If everything is fine. So this is the color stream. Of course, there's also a color stream, but I won't show it because I think the most important is to show the results. So here on the right-hand side, you can see all these hits and what were done in the past seconds. So it's completely live. I switch to the colors image. So here you can see it's a 2-lane street in Brussels. And you can see, you can also zoom in. So here at CD, so it's a diplomatic car, IU, so it's from Belgium, as you can see a B. So we can verify. It's here the license plate, then the country code, Belgium, it's a car, it's a Peugeot 3008, the model or for 5008. Then the color is gray. The speed estimation is 38, which is probably right because this street is restricted to 50 kilometers per hour and there is a traffic light not very far away. It's approaching and it's detected on the first lane. As you saw on the beginning, you have also the black and white image of this car. Of course, this is nice, so I will keep to the color images, and then you see of course what is necessary, the time, and the date, and which is interesting is also to see what your camera has automatically set as the best parameters for exposure, for the gain, and if needed, also the infrared power of our integrated infrared lens. So here you can very shortly per detection see immediately what the last detections and the last results. So I will click now a bit through. So here you can see the color, for example, here white, the C again diplomatic, so it's Brussels, of course. So CD AW090, so Belgium Fiat 536 approaching. I will go again with a lower. So here a Ford. So indeed, you can see the Ford Galaxy. It's black, 33 kilometers per hour, etc., etc. I can go like also other. You are seeing here, they are not coming anymore because I'm not anymore in the live stream. This is already a photo from now probably 1 or 2 minutes ago. But if I go to live stream, it's again, it will capture all the recent. So there's another one. So I can re-click and it's refreshed. So here you can see it's a Volkswagen T-Roc with a one USC 189. So it's here written approaching even 29. So apparently the traffic light is on. So I mean red, etc., etc. What is interesting here, you can see a search bar, so you can click, as I just said, but you can also search, for example, for vehicles in Germany. It's interesting because everyone we have from Belgium. So here you can see from Cologne, for example, it was 18 hours ago. I clicked, so it was yesterday afternoon. And as Germany is not very far away, and Germany has a particularly that you know from which city. So here's Cologne. So you can see also that it's not only Belgian plates, but also from Germany. So car HC 5361, for example, Audi, etc. Another example is, for example, from Aalen, also German city, which is not very far, I will see. So for example, this one, Mercedes, etc. Also, let's see if we can get, so I looked earlier, of course, if we have some black and during night. So this is an image of 4 o'clock in the morning. And this is the color image, of course, a bit blurred because we, of course, exposure. So you can already see that the camera itself recognizes the situation and change the parameters. So here the exposure, so the time, how long the camera is opening is now very long compared to the day images. That's why it's, of course, it's also a bit blurry. But for the license plate during night is, of course, the infrared is on. So here, even only with 10%, it's already enough to recognize very well. So here from Dortmund, or another is a city which is here, well known, I think Munich. Also here 1 hour ago. Also, I think this is, I will see if there's during night. It's almost night, so it's after sunset here in Brussels. So you can see here again the black and white and the color images during night. So this is an overview what you can see, but it's not only this what you can do. Of course, you can very easily parameter, or you can change parameters within the camera on the toolbox itself. So here you can see the how it's called, the time zone, etc. Then the region of interest. Here you can, how I just said, you can also see, or you can define by a polygon approach also the lanes. This is the base how the camera detects on which lane the car is driving. But as also, for example, in the camera, you can here change the parameters to say, okay, on this location, we want a minimum and a maximum exposure. For some reasons, we can also set the target brightness of the color image or the black and white image. So here it's the black and white sensor. You can see also the color sensor. I don't show it, it's almost the same, but here you can see it's very easy to change everything. And which is a nice feature also that, you know, we have not only some monitoring aspects, but you can also program some test campaigns which records automatically a video with the recognition results, so you can test yourself very easily what has been recognized versus the reality of, for example, 10 minutes or 1 hour, etc. So this is a very short and brief overview of our toolbox. It's, I think, very intuitive as platform. And so I come back to the presentation after the live demo. So then, of course, which can be interesting for you is to know, yeah, what is the performance? So the best thing is, of course, not to say something like, whoop, but to have some data, some real data. So we make a comparison even in Antwerp last month, so in March. And we compared here on the photo, you can see on the VMS sign, it's a 2-lane road. On the VMS sign on the top right, you can see 4 cameras. One of those is from MACQ, and the 3 others are from 2 of our main ANPR competitors. So this is our camera. And we took 2 hours during the day. Of course, one during noon, so with ideal conditions, sun, and we detected 700, so not MACQ, but there were in reality 721 cars, trucks, etc. And during this hour, we were able to detect, so the first column you see all the 4 cameras on top from MACQ, and the next column shows you the performance rate regarding the vehicle detection itself, so that the camera detects the vehicle as a vehicle. So MACQ was able in this example to detect 98.06% of all vehicles from the 721. And out of these vehicle detection, 99.72% the license plate we read well. That means if you multiply both columns, so vehicle detection times license plate reading, we have the overall performance. And in this 1 hour example, we detected 97.78%. And you can see the 3 other cameras from our competitors on the same side, on the same location. They are close, but we are on top. And we took also, of course, very interesting comparison during night. So from 10 to 11, there were less vehicles, so only 250. But the results are that our camera was detecting 97.6%, and we read 99.59% good, and this comes again to a performance of 97.2%. That means you can see we're more or less stable during day and night. Of course, night is still more difficult, so of course during day it should be better. Now the question is, which QCAM needs to be chosen for which application? Before I show you our recommendation, I want to give you some technical background so you understand why sometimes a choice is more appropriate than another camera, for example. So first of all, the key differentiator is, of course, the image resolution. So the QCAM 3, as I said at the beginning, it has 1 5 megapixel color lens. The QCAM 5 has two 5-megapixel lenses, one color, one black and white. And the QCAM 7 platform has two 12-megapixel lenses, one color and one black and white. That means, of course, if you have a tender or a client who wants 12 megapixel at least, of course, it's clear you need the QCAM 7. But, and probably one of the most important key differentiator is, of course, the vehicle density. That means it's highly linked to the embedded processor in the camera. And the QCAM 3 has an NVIDIA chip embedded, which allows to detect around 20,000 vehicles per day. This does not mean what really counts is, of course, the moment, the second. So that means if there are 10 cars during 1 second, it could be too dense for the QCAM 3. The QCAM 5, as you can see, has a more powerful embedded NVIDIA processor, a CPU and GPU processor, and it can detect 60,000 vehicles per day, and the QCAM 7 even 100,000 vehicles per day. This is very important to take into account if you have a situation, a location where you know, okay, there are 10 cars which can come at the same time. Of course, you need to take into account this fact. And as consequence from the vehicle density and the resolution, there is of course also the number of traffic lanes. So normally a highly dense road is also a bit bigger. So that's why it's linked. And so that's why the QCAM has 2 lanes. We recommend 2 lanes, the QCAM 5, 3 to 4, and the QCAM 7, 4 to 5. So if you have, for example, in Paris, a street which has 2 lanes, for example, the Rivoli Street, which is but at 5 o'clock, very, very dense. That means you can't choose probably the QCAM 3, even if it's here written that it's for 2 lanes, because the vehicle density is too high. That means in this case, probably the best choice would still be the QCAM 5. Now, I want to show you our recommendation based on all the technical background and also some specific features for all the cameras. So the QCAM 3, we are recommending those solutions. So for counting, for measuring the travel time, for monitoring parking areas, for allowing access control solutions, or to make some calculation regarding origin destination. The QCAM 5, we recommend to use it for average speed of why it's almost not a choice, but it's because it has on the QCAM 5 specific for average speed software features at the moment, which are of course needed for the homologation part. So also the blacklist management, we recommend to use a QCAM 5 because of course, if you look for a murderer, for example, you can't afford to miss one vehicle due to a very dense situation. And also the following modules like overtaking, low emission zone and restricted traffic zone in general, the illicit traffic or red running, the dangerous goods, everything we recommend for the QCAM 5, and also the carpooling solution, which has, of course, even its own camera solution, the QCAM 5P, the carpooling camera solution, because it is a group of cameras which are working together synchronously, and it's polarized. So this is based on the QCAM 5 platform. We recommend further also to use the QCAM 7 for spot speed, obviously because we have integrated the radar in the QCAM 7 to have the QCAM 7 Plus. For red light to have very brilliant images also in some for some countries where the driver needs to be detected. The railway crossing solution, the object detection, the automatic incident detection, the AID, or finally the intersection monitoring. So those applications, we are recommending to choose those cameras for these applications. And I want to close this webinar, this presentation, not this, but my part with this slide. I hope it was interesting for you. Of course, we could say much more. This is clear. And I hope that you gain a good overview of our QCAM series. And I think it's important to mention that and to know that MACQ, as a camera manufacturer, we are able to customize the products and our cameras for your specific project needs for your clients. So thank you.
Yes, thank you very much, Christoph, for this very interesting webinar about the QCAM series. You can go to the next slide. Yes, so we have gotten quite some interesting questions during the webinar, Christoph. Most of them have already been replied, but I think it's interesting for everybody that we discuss the questions in a bit more detail over here. So the first question we got was, at which distance is the camera from the truck? So in the presentation, you showed an example of detecting a truck. But the main question here, I think, is of the client, of this person, is what is the operational distance of the camera?
Yes.
So in which operational distance can the camera work on both day and night circumstances?
Yes. So as you can imagine, the picture what I showed from Paris, it's also to illustrate a good situation, etc. From an operational point of view, we are saying that around 30 meters, it's our standard operation distance, 25, 30 meters during all kind of situation, also during night. And during day, with very good conditions, we can even go up to 50, 60 meters. So, but I think in a standard situation, a good distance to have a good view and to have a good performance results, 25, 30 meters is very good.
Yes, indeed. That's indeed a very good answer. So perfect. Thank you for that. The second question that we got was, has the QCAM 3 camera also a black and white image?
It has not a black and white image because it has, of course, only the color lens. I think the question, I will expand the question. Of course, the ANPR world, of course, started especially with infrared, etc., with black and white. So the question is, of course, how we are doing during night when the infrared is on and we have only the color lens. This is the question. So of course, if you there's in the QCAM 3, there's still 8 dome LED infrared lens included, and they are still pulsing during night or also during day when the lighting situation requires it. And then the question is, yeah, but then probably it becomes red, etc. So our approach, and we think that is could be the future in general in the market, is that we, thanks to the powerful possibilities of software processing, we can put the image, the color image, with the software processing afterwards to have the benefits from the infrared illumination during night, and at the same time to have a good color image. And this makes it possible thanks to our software post-processing process. So of course, we don't have a black and white dedicated lens, but I think for all the issues regarding why a black and white could be interesting, we have a solution.
Yeah, indeed. So it's very important to understand that. So we don't have a black and white sensor on this camera, but due to algorithms, we can deliver both a black and white and color image. But the native image is, of course, a color image, and his gives us the capability to do whatever we want with the same performances. And we can also give a non-native black and white image, which is based on specific algorithms and so on. So yes, indeed, thank you very much, Christoph. A second or another question, and a lot of questions are coming in, so thank you for that. Another question that we had is, can you see the ANPR confidence level?
Yes, so on many locations. So first of all, you saw during the live demo the toolbox. Unfortunately, it was my mistake. I did not mention it. On the right-hand side in the toolbox, for each recognition, you see like, normally it's a green, and that means like 98, 100% sure, the confidence level. That our algorithm has well read the plate. So this is the first point where you can see very immediately. And of course, all our data, what we can see in the toolbox, but even more, is stored in the image itself as metadata. And in the metadata itself, you are able to see for each recognition a confidence level.
Yes, yeah, indeed. So perfect. Thank you for that, Christoph. Another question, and I think I will combine two questions with each other, is so the first one was, how do you calculate the speed? Do you have the geo reference, the area, to know the measurements in the image? So I think here the main question is, yes,
how do we calibrate? Yeah.
Calculate the speed. How do you need to do the calibration? Do you need to go on the street itself and mark an area? And
yes.
The second question that I would like to combine with this one is, how does the pan and tilt work? Maybe, I don't know, if we still have access to the demo camera, we can show just the environment of how.
Yes, definitely. I'm switching just to the demo. I think it's better than 1,000 words. I'm only I have a problem with my Zoom thing. I can't go to because I have a bar on top. So here, and normally I don't see here, should be written field of view somewhere, but I don't see myself.
Field of view on the third tab.
Yeah, I see it, but I can't because the Zoom thing with all the things are on top. Now, yes, perfect. So I click field of view. So this is the field where you can change very easily the pan and tilt. So here you have the live view. So currently no car, but it will come probably in a few seconds. And here the very easy sum button. So here the pan, if I click, it's of course remotely via 4G, etc. So normally you should on the live video see in a few seconds that it's moving. I will.
Yeah, it can take some time, and it are very minor changes. So.
Yeah, exactly. What? Up. Well, I need to click longer probably because it's up. Up. Could be better to switch to tilt. Now it's changed it completely. So. Up. I click again. Probably it will move a lot because I clicked to a lot. So I think what's needed is to have a bit more time than a few seconds to click and to wait a bit. That it's because to give more information. So in the camera, in each camera, there's a motorized support arm integrated. So it's mechanically. So if you click here, mainly there is a motor inside the camera, which is actioned remotely, and then you are able to position as you want. Of course, it's nothing. It's not meant to be done each day. So that's why I think I answered to the question. I hope that there's a motorized support arm. You can do it remotely, and directly from the interface.
Yes, indeed. So that's indeed the response. So you can see here the overview of how the pan and tilt can be set up in the camera itself.
And the first part of the question, please.
Yes, and the first part of the question was, how do you calculate the speed?
So the speed calculation is based, of course. So there are two ways, mainly. The best way, it will always be, that's why probably also the question, go inside to mark on the ground some very precise rectangulars to put the same points, then you are sure that the calibration is 100% perfect. Of course, we are also knowing that sometimes it's not very easy, and that's why we are able also to put more academic approach behind. So that means, by this, we can know, for example, the length of a car, a specific car model on which goes through. And so, for example, if the car is 5 meters and 10 centimeters long, we can calibrate by distance or from the distance the same calibration lines, thanks to a car or some other objects, thanks to our object detector, where we know exactly the distance. Of course, the base is always, we need something where we can calibrate the distance for sure and link it to the pixels we see on the camera.
Yes, indeed. So that's indeed the feedback on that. But if it's difficult to go on site, the camera can monitor the speed without going on site by giving in some parameters into the camera, like the height of the installation, specific lines that we can set up in the toolbox of the camera, and also with the object detection that can search for the infinity point of the camera or of the road. So this is completely possible. Another question that we got is, do the QCAM 5 and QCAM 7 have the same NVIDIA processor?
The QCAM 5 and the QCAM 7. It has not the same NVIDIA processor. So the QCAM 5 has the NVIDIA TX2, Jetson TX2, and the QCAM 7 platform has an NVIDIA Jetson NX. So that means it's different. And of course, if you go on an NVIDIA site, you will see immediately that the NX has more or less 4 times the teraflops of the TX2.
Yes, yes, indeed. So we do not use the same processing elements for those two cameras, as the QCAM 7 is, of course, the powerhouse of our QCAM series. It also has 12 megapixels, so a lot more pixels to process. It's also more dedicated for specific object detection and so on. So therefore, we use another NVIDIA processor to be able to handle that amount of processing that is needed. Another question that we got is, let me take a look. Yes, when will these cameras be available for deployment in real projects?
Yes, probably the most operational question is the QCAM 5 is immediately ready, and we have even already some cameras on stock. The QCAM 3, our goal is to have it during this summer ready for series, for operations, so on the field. And the QCAM 7 is for Q3, Q4 in the operations. So that means for our partners, for you, ready. Of course, a small remark to this, we as company were also depending on all the worldwide supply chains. So probably you heard about the Suez Canal issue last week or 2 weeks ago, I don't know. But of course, as we have very powerful chips embedded, we are also depending on this. So this is the only dependency we have to deliver on time.
Yes, indeed. So thank you for that. Another question that we got is the performance high enough for concurrent use? For example, and with concurrent use, they mean so 2 different applications at the same time within one camera. So for example, detecting traffic violations at the one side, and at the other side doing counting, classifying of vehicles.
Yes, I understand. Very good question. And of course, it's a complete yes. We are able to do with one camera multiple application at the same time. And I think it's also one of a big advantage, because we not only produce the camera, but also the software with all the modules. And indeed, the same camera can, for example, count vehicles, make some statistic, but also can be used for average speed, to calculate the average speed within 2 cameras, etc. So the cameras can be used for many applications at the same time. Yes.
Yes, perfect. I'll have a look to the questions. I will go to one more question, and I'll then see if there are some other questions, because there are quite a lot. Can the live view of the camera also be streamed to a CCTV monitoring platform, like, for example, Genetic?
Yes, so it's regarding live stream, we are able to provide a live stream from our camera via RTSP. It's our standard, but also via ONVIF protocol. So we have the ONVIF protocol S profile. That means this is, of course, a standard which is, of course, very important in the CCTV world. So I think important for this question. And yes, we have the capability to have on-with protocol standard on these cameras.
Yes, yeah, indeed. Thank you very much for the feedback, Christoph. I have another question that is also quite interesting, a bit similar as one of the first questions, but also quite interesting. Is there a distance range list for the different cameras in the different situations? So are the distance ranges similar for all the cameras? And how does this work on different applications?
So, of course, you can imagine that a camera with 12 megapixel versus 5 megapixel, we can easier go far away. Then it's, and from the optical point of view, I can completely say yes, we have different possibilities to look far away from the optical point of view. Then, of course, for operation, it's not only the optics, but of course, the performance which is necessary. So as we are bounded by an embedded processor, we need also to take into account the amount of pixel we need to process at the same time. That means the 12 megapixel, if you look far away, you still need to see the license plate in a high resolution format. You need to take into account the 12 megapixel as it is. You can't downgrade it to have an optimal processing of the image itself. So it's a question of performance on a very a very long distance, for example, the QCAM 7 versus a QCAM 5 or a QCAM 3. The QCAM 5 and QCAM 3, they have the same optics and the same megapixel. There, it's more or less the same. But we have with the QCAM 7, indeed, possibility to look far away. This, yes.
Yes. So yeah, thank you very much, Christoph. We still have some open questions, but we will answer those personally by email, as we still have quite a lot of questions otherwise to answer. The only thing I still want to say, because we got also some questions about that, is that the cameras can of course also be connected with our back office solution to manage all the metadata, send images, send metadata, send all the information possible, monitor the cameras. So we also have, of course, a complete homemade solution for that that is completely available, but was not presented in this webinar to of course, timing. But we also have a solution for that. So thank you very much, everybody, for joining. We had, of course,
thank you.
A lot of participants. Very interesting. Thank you very much. Thank you, Christoph, for giving such a good demonstration and information.
Yes, you're welcome. Yes, thank you.
So thank you very much, everybody. You can go to the next slide, Christoph.
Yes, I will go to the next slide.
So all our webinars will also be available, or are available on our website. So if you are looking for a particular webinar, you can rewatch them on our website at www.macq.eu/webinars. So they are all available. Also this webinar will become available probably tomorrow or in the next coming days. And our next or our upcoming webinar will be by the end of May about smart parking and the QCAM Smart series. So thank you very much, everybody, for joining our webinar. Thank you, Christoph, and have a good day, everybody, from all over around the world. If you have some specific questions, you can contact us also directly. Our contact details are also available on the website. Thank you.
Thank you. Bye-bye.
Thank you. Have a good day, everybody. Bye.